Morning technical course students. Today I would like to talk to you about compression readings in pounds per square inch. We discussed the compression gauge and its importance in automotive and diesel running testing of the engine. These ASE type questions related to the pressure readings that you will get from your gauge are very, very important. One or more of these examples you need to understand, because they will throw test examples like this exactly like on the ASE test. Our specification for this diesel engine is 450 psi. So anything above or below that is a serious problem. In this example here, we have 450 pounds on the first cylinder, 0 readings when our compression gauge is in this port, 0 with compression gauge in this port, 450 here. So if they're side by side, the most highest probability of what is wrong with this diesel engine is a blown head gasket. This is an example of a blown head gasket that actually blew while my students started the engine up. It blew right across here. So when we say 0 compression in these cylinders with the gauge hooked in this, and I'm turning the engine over several revolutions to get my readings, all the pressure is going into this cylinder. When my gauge is here, all of my pressure goes into this cylinder. So when we have side-by-side readings, that is an almost 100% indication of a blown head gasket. Example number 2, where we put the compression gauge in and we test each hole one at a time with a compression gauge in one hole at a time, and a 0 reading here, 450, 450, 0 there, would not be a blown head gasket. That would be a burnt valve or a misadjusted valves that are hanging open. In certain possibilities, depending on questioning the customer about what happened and when it happened, a hole blown through a piston from overfueling could do that. But the most highly probable readings on 2 adjacent cylinders not paired would be valves that were burned. Another example that will be on the ASE test is if all of these came from the factory at 450 pounds, how can we have compression that's higher than specification? One of the examples or test questions, probable answers, could be that a wrong piston is installed. Well, that does not happen in a factory-built engine or any engine I've ever run across. The answer to this question would be combustion chamber fouling. When an injector does not atomize fuel, when it goes in there and gets partially clogged up or overfuels, it will start building up carbon. And carbon will build up on top of the piston, reducing our cc's of our combustion chamber and cause the compression to rise. So this would be fouling of a cylinder, which would require the engine to be disassembled, the problem repaired, the injector replaced, and the combustion chamber, cleaned out. This is an example which I'll give you of, I'm going down the road, so this truck is running, or this car is running, so we know it has to have 450 pounds of compression to actually run. Well, it gets towed into your shop with this family aboard in your waiting room, and they said it doesn't, it just went down the road and stopped. You put the compression gauge in and you get 200 pounds uniformly across the whole test, which the engine could not have been running unless it had 450 pounds of compression. So this would be an example of the timing junk. The intake valves and the exhaust valves got out of sync with the 4-stroke cycle of the pistons. So this would indicate a timing that has junk time, as it would be called, between the relationship between the camshaft and the crankshaft. So, and then we could have bent valves on a diesel engine because it's an interference engine. So this is some examples of the importance of your understanding of the readings that you get when using the compression gauge.